So last lecture we talked about this guy. We said, how do you do it if it's a strong base, weak acid? So now we're going to continue on and we're going to talk about the reverse. So what if it's a strong acid, weak base? Okay. So remember we said our hint is if I have a strong acid, weak base. If they're both, if they're not the same thing, so remember strong is just neutral. Whichever one's the strong guy is over going to come the weak guy, and so it's going to end up with an acidic solution. But let's talk about how we know that. What's actually happening? So I've got a weak base, NH3, here's my weak base, ammonia, with my hydrochloric acid, so weak base, strong acid, these are on your table at the beginning of this chapter. Okay. Get my ions that are going to form. Okay. And so then when they react, I have my ions, and so let's write the complete ionic equation. So the complete ionic equation is going to be NH3, and then my water, because remember if it's weak, we don't dissociate it. Okay, so if it's a weak, it stays the same. HCl is going to separate to H plus and Cl minus, but we could write H3O plus, same difference. So I take the weak base, I just copy it down, I take my HCl and I separate it. Okay? And then my NH4 is going to be floating around, Cl minus, and my water. Because remember, you're always going to get a salt and water. Okay? So now we have my salt and my water. Alright, so let's see what's on both sides. So your Cl minus is on both sides, so that's going to cancel out. So all you're going to have left is your NH3, your H3O plus, which came from your H plus, your NH4, and your water. So this is the base, this is my conjugate acid. So all that I have left is my acid. Okay? So if I had equal molar present of my starting material, of my base and my acid, then it's going to end up producing an acidic solution. Okay? So equal molar produces acidic solution. Now how acidic it's going to be, how strong, depends on the Ka. So remember, the larger the Ka, the more acidic the solution. And also remember, if you see Ka, that's my hint, oh, this is probably going to be acidic because they're talking about it in terms of Ka. If it was going to be basic, they would talk about it in terms of Kb. So which K they give you gives you a hint as to what type of solution is going to be, acidic or basic. Alright, so let's look at an equation, or a problem I mean. So it says find the pH of 0.132 molar NH4Br. Is this solution acidic, basic, or neutral? So what am I looking for? I want to know the pH. And then after that, I want to know, based on the pH, is it acidic, basic, or neutral? I want to know what's going on. Alright, so what did they give me? So they gave me 0.132 molar of my NH4Br. And they gave me the Ka of my NH4 plus, which is 5.6 times 10 to the negative 10. Alright, so that's what I have. So I'm looking for pH. So your first thought is, okay, pH is equal to negative log of the H3O plus concentration. That's what your first thought's going to be. Well, the only way you could plug some sort of concentration directly into here is if it is strong, and because this is pH, it has to be a strong acid. So the only way you can plug it directly in is if it's a strong acid. So then I have to go and say, okay, what is this? This is either an acid, a base, or a salt. Those are my three choices. I gotta figure it out. Is it an acid, is it a base, or is it a salt? Okay, so then I gotta look and see, well, what other things do they give me? So remember we have our clues, right? So the clues down here is they gave me Ka. Okay, so you might be leaning to acid because there's Ka, but remember we have something in a parenthesis after the K. So anytime there's something in the parenthesis after the K, this is my big, hello, wake up, pay attention, kind of red flag that it's a salt. So this is telling me that the NH4Br is a salt, and the ion that's doing something is the NH4+. Okay? That's the ion that's actually going to be doing something. Okay? So kind of like we saw here, here's my NH4+. It's the ion actually doing something. So now I know, okay, it's a salt. All right? Now, I can actually answer this question right off the bat. Because remember the trick I taught you. The trick I taught you is if we have this in parentheses, it means it's a salt, and if they tell me it's Ka, then it's telling me it's going to be acidic. So I automatically know off the bat that it's acidic. Okay? Now we can check that with the pH we're going to find. All right, so if it's a salt, I can't just use the pH equation directly. If it's a salt, it means I have to do an ice table. So the first thing I write is whatever is in parentheses. NH4+, plus it's always water. If it's acidic, this is my acid. So if he's my acid, he's going to donate the H+. So if he loses an H+, you have NH3 left, and he's going to give the water the H+, so he gets H3O+. All right, and then we do our ice. Okay. To start off, how much of my NH4+ I have is in here, because one of the ions here is NH4+. No NH3s, NH4+. So this is 0.132. Water is a liquid, so remember we don't count him. 0, 0. See how the setup's the same? He's going to go away, so he's a negative. He's positives, and it's always a 1 to 1 to 1 to 1 ratio. Problems are going to get really similar. You'll see how this chapter is very similar to the setup from last chapter. All right, so if I'm trying to figure out the pH, pH is negative log of H3O+. So here's my H3O+. I know if I'm trying to find H3O+. H3O+ is X, so I need X. So there's got to be something else they gave me that's going to help me find my X, and that's my Ka. So now we need to write out the Ka. So Ka is equal to NH3 times H3O+, whoops, all over NH4+. Remember, water's a liquid, we don't include it. I know the Ka, that's 5.6 times 10 to the negative 10. This is X times X over 0.132 minus X. Okay? So let's rewrite that. So 5.6 times 10 to the negative 10 is equal to X squared divided by 0.132 minus X. So now we're like, okay, well the bottom isn't squared. So I would love to not have to do with that square at the bottom. So what did we say? We could do an approximation. I can get rid of the bottom if my X is much less than 0.1. If my Ka or Kb is very small. And if the percent ionization is less than 10%. Those were my rules for my approximation. So this is really small, 10 to the negative 10. So we're like, yep, that's good. Okay, so we're going to go ahead and assume that we can approximate. So we're going to take that out. So 5.6 times 10 to the negative 10 is equal to X squared divided by 0.132. Multiply this over, you get 7.392 times 10 to the negative 11 is equal to X squared. Square root both sides, and X is equal to 8.598 times 10 to the negative 6. So now we could do our second approximation. Is X less than 0.1? Yes, by a lot. So before we get too excited, let's check our percent ionized. So percent ionization is equal to my X over my initial times 100. So my x is 8.598 times 10 to the negative 6. My initial was right here, the 0.132 times 100. That gives me 0.00651%. Really, really small percent. So, since that's so small, I think we can assume that's good too. All right, so now we know our x is good, it's a valid number, we're happy with it. Now, what were we trying to find? What was the whole point? Oops. pH, that's what we wanted. We said pH is negative log of my H3O+. H3O+ was equal to x, which I have. So I know that this is also equal to my H3O+ concentration. pH, negative log of H3O+. Plug it in. And that gives me a pH of 5.07. Then I just think about it, what did we say? If it's 5.07, is that less than, equal to, or greater than 7? It's less than 7. So if it's less than 7, what type of solution is it? Acidic, which is exactly what we said at the beginning of the problem. So we got our pH, we have the acidity, and we're done with the problem. Okay? So this one's very similar to the flip. So this one was weak base, strong acid, very similar to the one we did last lecture. That was strong base, weak acid. All right? So now we've done strong, strong, both combinations of strong, weak. Now we need to do weak, weak. So the next lecture we're going to talk about weak, weak.